Good morning, everyone. I'm Narmatha, Assistant Professor, Department of Cybersecurity, working in Dr. S.N.S. Rajalakshmi College of Arts and Science. In today's topic, we'll discuss about process states and operating system. So before that, we'll see about multiprocessing and thread. Then we'll get into process states. First one, multiprocessing. In a multi-user and multitasking operating system, where many users execute programs simultaneously, the processor is able to execute several processes at a time. For example, one process might require printing a document, while another process might require input from the keyboard. This ability of a process to handle multiple processes at the same time is called multiprocessing. A process might be divided into many smaller independent tasks that can be executed simultaneously. For example, a computer can display the time and accept input from the user simultaneously. The two tasks are independent. Each independent task in a process is called thread. When multiple threads executed simultaneously means it is called multithreading. The generic name for both multithreading and multiprocessing is multitasking. Although multiprocessing and multithreading seems to be very similar, but they are different. The difference lies in the way in which the process and threads occupy memory address space during execution. Two threads of the same process share the same address, but two processes running simultaneously do not share their address space. Process enables system to perform and track simultaneous activities. Processes transition between process states. Operating system perform operations on processes such as creating, destroying, suspending, resuming, and walking. Next one, process states. When a process executes, it changes states. The current activity of a process determines the state of the process. A process can be in the following states: new, running, blocked, ready, terminated. New, when it is created; running, if it currently has the CPU; blocked or waiting, if it is waiting for some other event to happen before it can proceed; ready, the new process that is waiting to be assigned to the processor; terminated, a process that has finished execution. So this is the pictorial representation of process state. So we have only three states: ready, running, blocked. So in between that, we have many operations. We are using many methods. So by the use of that methods, we are executing a particular process. Working of process states is given in this. An operating system kernel that allows multitasking needs process to have certain states. Names of these states are not standardized, but they have similar functionality. First, the process is created by being loaded from a secondary storage device into main memory. After that, the process scheduler assigns it to the waiting state. While the process is waiting, it waits for the scheduler to do a so-called context switch and load the process into processor. The process state then becomes running and the processor executes the process instruction. If a process needs to wait for a resource, it is assigned the block state. The process state is changed back to waiting when the process no longer needs to wait. Once the process finishes execution or is terminated by the operating system, it is no longer needed. The process is removed instantly or is moved to the terminated state. When removed, it just waits to be removed from main memory. So from this, you can understand about what is multiprocessing and multi-threading. We can call multiprocessing and multi-threading as multitasking concept. Then we have seen the process states. So by this video, you can understand all these concepts. Thank you.